So let's continue lecture 1 for part 2. For subtopic 2.2, first order linear differential equation. At the end of the lesson, students should be able to solve first order linear differential equation by means of an integrating factor. Now we look at the linear first order differential equation. A linear first order differential equation is one of the form dy dx plus p of x times y equals to q of x. The solution must be on an interval where both p of x and q of x are continuous. The usual solution to the differential equation is to change it to an exact differential equation, that is by means of an integrating factor. This integrating factor is denoted by v of x and is given by the formula e power of integrations of p of x dx. By multiplying both sides of the equation by the integrating factor v of x, you change the left-hand side of the equation into the derivative of the product v of x times y. As line 1, we have multiplied both sides by the integrating factor, and we change the left-hand side to the derivative of the product v of x times y. And then we can solve the above equation by integrating both sides with respect to x. As we know, the integration is an antiderivative, so we end up with v of x times y equals to integrations of v of x times q of x respect to dx. So what we're just gonna do, integrate the right side, and we're gonna have the solution of the differential equation. Okay, now let's discuss the example 5. Solve dy dx minus y over x plus 1 equals to x. So first, what we're going to do is we write the differential equation into a linear first order differential equation. So we have dy dx minus 1 over x plus 1 times y equals to x. As we compare this equation with a linear first order differential equation, so we have this is actually a p of x, and we have here as q of x. So we have identified the p of x is a negative 1 over x plus 1. So next we're going to find the integrating factor v of x. So to find the integrating factor, we use the formula e power of integrate of p of x dx. As we identify the p of x is negative 1 over x plus 1, so the integrations of negative 1 over x plus 1 we have as negative ln x plus 1. So in this case we just ignore the c, and as we simplify as e power of ln x plus 1 power of negative 1 by using the properties of ln, so we can simplify the e power of ln x plus 1 as 1 over x plus 1. So this is a integrating factor for our differential equation. So since we have already defined the integrating factor, then we're going to multiply both sides with an integrating factor v of x. So we're going to have 1 over x plus 1 times the left hand side, which is dy dx, minus 1 over x plus 1 y, and also to the right hand side 1 over x plus 1 times x. So on the left hand side, we turn into the derivative of a product integrating factor times y. So we simplify the right hand side as x over x plus 1. Then by integrating both sides respect to dx, we're gonna end up with 1 over x plus 1 times y equals to integrates of x over x plus 1 respect to dx. Since the integrations of differentiation is actually cancel out, so we just need to integrate on the right hand side. So in order to integrate of x over x plus 1 by using long division, since this is an improper fraction, so we have 1 minus 1 over x plus 1. So we have before is 1 over x plus 1 times y. So we have x minus ln x plus 1 plus c. So we move 1 over x plus 1 to the other side. So we left with y equals to x plus 1 times x minus ln x plus 1 plus c. So we have a general solution of the linear first order differential equation. Now we look at example 6. Solve differential equation r dt over dr minus 2t plus r equals to 0. Okay, for this example, I want to use an integrating factor. First, we simplify the equation. R dt dr minus 2t equals to negative r. Then, in order to eliminate r, so we will divide all the equation by r. So we're gonna have dt dr minus 2 over r times t equals to negative 1. So we have formed the equation into a linear first order differential equation. So next, we identify negative 2 over r as p of r and negative 1 as q of r. So next, we find the integrating factor v of r. equals to e power of integrations of negative 2 over r dr. So we have negative 2 ln r, and we simplify as ln r power of negative 2. As we simplify exponent power of ln, so we have 1 over r squared. So our integrating factor is 1 over r squared. After that, we multiply both sides with integrating factor. So we have 1 over r squared times, on the left side is dt over dr minus 2 over rt, and on the right side is negative 1. So as we know, on the left side we can simplify, or we can turn into differentiations of integrating factor 1 over r squared times t, and we simplify on the right side as negative 1 over r squared. And then by integrating both sides, we're gonna left 1 over r squared of t equals to integrations of negative 1 over r squared dr. So integrating a negative 1 over r squared, we're gonna have 1 over r plus c. Next, we bring 1 over r squared to the right, and we left t as r squared times 1 over r plus c. So we're gonna have r plus r squared c. Example 7. Solve e power of t dr dt plus 2e power of t times r equals to 3. But this time we are given an initial value r of 0 equals to 2. So in order to use an integrating factor, so we have e power of t dr dt plus 2e power of t times r equals to 3. So in order to turn this equation into a linear first order differential equation, so we have to divide the whole equation by e power of t. So we have here as dr over dt plus 2r equals to 3 over e power of t. So we identify the p of t as 2. Then we find the integrating factor v of t as e power of integrate to respect to dt. So we have e power of 2t. So this is our integrating factor. Then we multiply both sides with integrating factor v of t. So we have e power of 2t times and same goes to the right side. So we simplify the left hand side into a derivative of e of 2t times r equals to 3, and we simplify on the right side, so we have 3 e power of t. Then by integrate both sides, so we have on the left is e power of 2t times r, and on the right side we have integrate 3 e power of t respect to dt. So we integrate on the right, so we have 3 e of t plus c. And then by bringing e of t to the right, so we end up with r equals to 3 e of t plus c divided by e power of 2t. So we can simplify as 3e power of negative t plus c e negative 2t. Since this example, we are given an initial value, which is for t equals to 0, we have r equals to 2. So we substitute into the general form of differential equation. So we have 2 equals to 3e times power of 0 plus c e power of 0. So we have c equals to negative 1. Then after that, we put back c into the general equation. So we have r of t equals to 3e power of negative t minus e power of negative 2t. So we have the particular solution of the differential equation. And lastly, example 8, solve y plus 1 dx over dy plus x equals to 2y minus 1, and we are given an initial value x equals to 1 and y equals to 1. First, let's rewrite the equation as y plus 1 dx over dy plus x equals to 2y minus 1. So in order to form linear first order differential equation, we will divide the equation with y plus 1. So we have dx over dy plus 1 over y plus 1 times x equals to 2y minus 1 over y plus 1. And we identify the p of y as 1 over y plus 1. So next, we're going to find integrating factor, or v of y, as e power of integrate p of y, which is 1 over y plus 1 respect to dy. So we have e ln y plus 1, and by using the properties of e power of ln, so we end up with y plus 1 as a integrating factor. Okay, next we multiply both sides with integrating factor v of y. So we have y plus 1 times dx dy plus 1 over y plus 1 x, and same goes on the right side, y plus 1 times 2y minus 1 over y plus 1. So on the left side, we turn into the differentiation of integrating factor times x, while on the right side we simplify the equation, so we have 2y minus 1 as we cancel out y plus 1, and then we integrate both sides with respect to dy. So on the left side we have y plus 1 times x, and we integrate the right side to y minus 1. We have y squared minus y plus c. So we have x as y squared minus y plus c over y plus 1. But since we have an initial value, so we have to substitute into our general solution. So when x equals to 1, we have y equals to 1. So x would be 1 equals to 1 squared minus 1 plus c over 1 plus 1. So we have c equals to 2. Then we substitute back c into the general solution. So we have x of y is y squared minus y plus 2 over y plus 1 as a particular solution for this example. So that's all for lecture 1. I'll see you on lecture 2.